So good morning, everybody. I'm Sarah Ryan, one of the co-chairs of the Cyanobacteria Harmful Algal Bloom Network. And this is the October 12th quarterly meeting. And Becky, would you like to introduce yourself, and looking for Jamie as well?
Sure. Becky Stanton, Office of Environmental Health Hazard Assessment, the second co-chair of CCHAB. Welcome.
And I think Jamie was having a few troubles. And I apologize for kind of the extra that's going on. I'm going to have to leave the meeting for a part of it just because of a Fish and Game Commission hearing that's going on that I have to jump onto. But welcome, everybody, and hopefully you can see the agenda, and we appreciate you coming to today's meeting. We're going to start with, we have quite a few great presentations that are happening today, and also our regular regional coordinator Hab Reports. But let's just please make sure that your name and affiliation is in the chat so we can make sure we've got good notes. So open to any announcements that anyone would like to make first? Just so you know, we've got on the CCHAB website, we are putting, no longer putting specific minutes, but there is a link to a YouTube channel of the California Water Monitoring Council, Water Quality Monitoring Council, and a video of the meetings is placed on that link. So you can always go back and watch the meetings. The minutes include basically where to find the agenda item in the video. So it's always great to be able to go back and look at the things that we're talking about and accomplishing. And if you are interested in any of these slides, please contact of the presentations today, please contact the presenters directly, or if you have trouble with that, reach out to one of the co-chairs. All right. Becky, did you have any announcements?
No, I'm good. Thank you.
Okay.
Oh, I guess I could say the S Hub Symposium is happening in starting on the 23rd, 24th, depending on your timing, and look forward to if folks are there. I know we have a lot of great sessions and probably a lot of us are presenting, so look forward to those who are participating. And they still have virtual registration, I think, through the 16th.
Yes. It would be great to see who's planning on going and do a little coffee hour or something of the California attendees. I know I signed up to go because there's so many great things that are going to be covered during this session or during that week. So if anybody wants to reach out, get together during the Hab Symposium over in Albany, please put a message in the chat or reach out directly to me. Becky, I can't wait to see your poster. It looks very interesting.
Thanks.
All right, well, we are a couple minutes early. I know we've got regional coordinators, Hab Reports, and since we don't have anything else, let's go ahead and go into our regional Hab Reports. So starting with Region 1, Mike, are you on?
Hey, yes, good morning. I don't have anything formal prepared, but I can kind of give you a summary of what we saw this season. In the North Coast region, we did recommend 2 danger postings at Big Lagoon and Copco Reservoir. We had 1 warning in the Lower Klamath National Wildlife Refuge. And then the rest of our recommendations were either cautions for planktonic blooms or toxic algae alerts in rivers. We did get a report of 1 dog death and 1 dog illness. We did have 1 confirmed human illness in the region, and then also another reported human illness that I think we are still looking into. We participated in the pre-holiday assessments for Memorial Day, 4th of July, and Labor Day. During these assessments, it did result in warning postings for Lake Pillsbury, but that has since been lowered to a caution. And we are participating in the pre-holiday extension. So we collected samples at the end of, or the beginning of this month to see if any of these have gone down. It's also worth noting that the Labor Day assessment did result in danger recommendations for Big Lagoon and Copco Reservoir, as I kind of mentioned earlier. Other things to report, we are working, well, many of you know we released the benthic report the beginning of this year. As kind of a follow-up to that, we are going to be releasing a Spat report, hopefully soon. And in this report, we looked at various deployment links for spats that are deployed in rivers, and we will be making a recommendation on the appropriate length for determining cyanotoxin presence in the river and how this may relate to benthic cyanos in the river. But that's kind of all we've got going on in a nutshell. I'll take any questions, or if Rich is online and wants to comment any further.
I think you should keep it, and we'll just be busy tomorrow to make sure you're clear for it. Sorry about that.
Alrighty, thank you.
Thank you, Mike. And I don't see Rich on there, so. All right, Region 2, Christina.
Hi, this is Rebecca Norton-Holt. I'm actually going to do the update.
Thank you.
Yeah, so I think the most noteworthy thing I can tell you about is we had a marine algal bloom, a red tide in the San Francisco Bay. It started at the end of July, and it went through August, and it resulted in pretty extensive fish kills in the bay and also in Lake Merritt in Oakland, which is connected to the bay. So that was pretty crazy to deal with. And so also Marissa, Carly, Becky, if you want to add anything about this, feel free to jump in. It was just like a great collaboration with all these different agencies to deal with it. And yeah, I don't want to get too into the weeds about it, but if you have any questions, feel free to talk to me offline or now. And then we also did the holiday assessment at 9 sites throughout our region, and we will be going back later this month to a few of them that had warnings, including, or caution advisories, including Lake Merritt. And just as always, shout out to East Bay Parks for all the great work they do in our region. And Christina, if you have anything to add, feel free.
I'm good,
Yeah. I see Caitlin has her hand raised.
Hi, Rebecca. Yeah, just a really brief question. I was curious if there's a final number, at least of the recorded fish kill. I know all the public, public facing numbers I saw was in the tens of thousands for Lake Merritt specifically.
Mm-hmm.
And I just know that there's additional surveys being taken place by CDFW and others, and just curious if there's an updated estimate.
That's a great question. There's not an estimate as far as I know, and I think it's going to be really hard for them to ever decide on a number because CDFW and SFEI, I think we're working on trying to tally up all of the numbers, but a lot of it is from public reporting, so you don't know how often the fish are being like double counted or triple counted. So I think sort of like an order of magnitude is maybe the estimate that they would get, but I don't think we're ever going to get like a real solid answer.
Understood. Thank you.
I had a question about so the fish kill was due to the low dissolved oxygen. Is that what was going on? And what kind of numbers were you seeing there? And also what kind of cyanobacteria genera?
Yeah, so there was definitely low dissolved oxygen. It went down basically to 0 in the bay and in Lake Merritt. And it was Heterosigma akashiwo is the species. And so we think a lot of the fish kills are due to dissolved oxygen, but we did start getting reports of dead fish before dissolved oxygen dropped. There's extensive monitoring that happens in the bay that SFEI does for the nutrient management strategy. And so they have oxygen data from before the red tide happened and then once the fish kill started. So, and someone else could probably explain this better than me, but there is a mechanism where this algae can be toxic to fish outside of DO. So we think that started happening a little bit, but then a lot of it was due to the dissolved oxygen. And I see Marissa just put something in the chat that has more background info if you want to read up on it.
Thank you for that.
Yeah.
And maybe it could be a topic during one of the next meetings if you wanted to put together a report. I could talk to the co-chairs, but I think it's fascinating how you dealt with it, what you had to go through.
Yeah, thank you. And big thanks to all the partners we worked with. So that's it. Thanks.
Thank you. All right. Region 3, Melissa.
Hi, can you hear me okay?
Yes.
Sorry for being late, y'all. Yep, so we participated in all of the statewide pre-holiday assessments this year, and also the first round of post-holiday follow-up monitoring. So we also collaborated with a partner in Monterey County to do some sampling for us also for the holiday seasons and for this post-holiday follow-up. I believe they're monitoring probably close to 4 different water bodies. We've been monitoring up to 6 water bodies, and we're planning to continue those post-holiday follow-up for the next couple of months as long as we can utilize the contract funds that we currently have in Region 3 to do some of these HABs monitoring. So the lakes that I'm more familiar with because my group has been monitoring them are Oso Flaco Lake, Lopez Lake, Laguna Lake, Lake San Antonio, Lake Nacimiento, and Santa Margarita Lake. And unfortunately, we've been having a pretty persistent bloom at Oso Flaco Lake. That's one of our troubled water bodies. And there was also a report recently, I think in the last month or so, that they were seeing some fish behaving a little sickly, and they were having some mortality there. And unfortunately, they weren't able to preserve one of those specimens in the time frame that would need it to be for a tissue analysis. But they did reach out to our illness work group and got some support from CDFW and some other folks. And so the park rangers out there know that if they do continue to see mortality or sickly fish, that they are to contact some folks at CDFW and see if we can get some of those tissues analyzed for Oso Flaco Lake. And sorry, I'm not more organized, but that's basically what's been going on in Region 3.
Any questions for Melissa? Melissa, I have one, and that is, could you explain the sickly? Like, is it just their behavior, or was it something else?
I think it was their behavior. It sounds like they were kind of swimming slowly. They were kind of gasping for air, and they just like weren't they weren't very lively, I guess is the right word for it. So I think a lot of the behavior they were seeing was just kind of like lethargy, kind of, where the fish just looked like they were, not doing so well, and they were kind of coming out of the creek too, and they were, leaving the lake. And so they thought maybe that was part of it too, is that the lake was pretty bad this year. I mean, it's green almost year round, but they think some of the fish were leaving the lake. And unfortunately, the creek has been showing symptoms this year as well. And so we started monitoring the creek. I guess last year was probably the first time we started monitoring the creek as it passes through Pinto Creek
or sorry, not Pinto Lake, excuse me, Osoflaco Creek exits the lake and then, confluences with the ocean there at the beach, and they were seeing these fish a little bit further downstream. So it may also be influenced by, they get some tidal flux that pushes up into the creek. And so they don't know if it was a combination of the fish trying to leave the lake and then maybe getting into the saltier water, the brackish water. But yeah, they basically just said they were behaving oddly, and they did find some fish that had died. And so they weren't sure if it was HABs related or not, but that was one of the kind of alarm bells that went off in their head, especially because it was happening around the monitoring events for the HABs assessments for the holidays. And so they reached out.
Thank you for that. I noticed Jamie, our other co-chair, has joined a little while back, and I'd like to stop for a moment and have Jamie introduce herself.
Unmute. Yeah, sorry about that. I have a big thunderstorm and I was having an internet computer issue, but we're good. I'm on. But I'm Jamie Smith. I'm the third co-chair. Thank you for pausing to introduce me, and I'll help you host when you have to jump off any other meetings. So, yep, cool.
Thank you, Jamie. And we did. I couldn't make all of us co-hosts, so I made Becky host, and she started the recording. And again, if people join late, please make sure that your name and affiliation is in the chat. All right, thank you. Thank you, Jamie. All right, so is Emily or anyone from Region 4 like to report out?
I don't think Emily is on, but there was some monitoring in some local lakes, particularly some private lakes on by HOAs, and that information is on the map. Sorry, don't have anything prepared for the LA region, but perhaps another water manager from the LA region would like to add anything. I think we have some online.
And I'd just like to add too, I think there was, it kind of spans Region 3 and Region 4 and into Region 8, but there was a marine Demoic acid producing bloom that happened in August that right now it's kind of wound down, but there was an associated marine mammal stranding event with over 250 marine mammals, including sea lions, fur seals, and some dolphins that stranded. And we were SCORP and some of the other coastal groups were working on responding to that event as well.
What was that, a HAB related stranding or?
Yeah, there was a large kind of Pseudonychia bloom that kind of spanned up from like Santa Barbara all the way down into kind of northern Orange County area.
Yeah, I put the August HAB bulletin in the chat, the link. Yeah, and I think that had close to 400, but I know not all of those have the same level of documentation just because of the amount of workload they were dealing with.
Yeah.
Thanks, Becky, for putting that link in the chat, and thanks, Jamie, and Marissa for the update. All right, Region 5, Karen.
Hello. So we had some of our typical big blooms this year, including Clear Lake, which I'll let Sarah talk about more, but also San Luis Reservoir and Eastman and Hensley Lakes both have current danger warnings there with really, really high levels of cyanotoxins. We actually are doing a special study there that's going to be finishing up this summer, where we're collecting nutrient data, cyanotoxin data, and also getting actually some eDNA this year, which is exciting. So we also have some blooms still. Big Break is dying down now, but had quite a bloom this year. In terms of rivers, we saw blooms on the North Fork American, a benthic bloom, and also on the Kauai River. The Kauai River was one that we previously hadn't had huge blooms reported, but we did this year. which resulted to quite a few both human illness reports, and some concerns with drinking water systems there as well. So that was kind of a new challenge for us, was dealing with some of these very small drinking water intakes. And we had to write some quick protocols and think on our feet there. In addition to that, we had blooms widespread across the Delta. And let's see, yeah, so we had, in terms of human illnesses, we had over 10 reported. Some of those were found to be related to HABs, and some of them were not related to HABs, as is typical. And then we had some major fish kills as well in Clear Lake, as well as in North Natomas Regional Park near Sacramento here. In addition to that, we did participate in all 4 pre-holiday assessments and had lots of participation, which was great from some new places as well. We also started up some routine partner monitoring. So we had routine monitoring in the American River corridor, which was really great, since they did end up having some blooms this year. And Restore the Delta in Stockton also came on board and monitored 7 sites around Stockton this year, filling a really critical data gap in that area with the large population. So in addition to that, just want to plug, we're working on a Delta Hab workshop with the Delta Council, and that'll be coming up, I think, next month. So if you're interested in that, please sign up. Thanks. Any questions? Otherwise, over to Sarah for a little bit of a Clear Lake update.
Hi, folks. So I'm Sarah Ryan. I'm also the environmental director for the Big Valley Band of Pomo Indians, and we are doing the cyanotoxin monitoring on Clear Lake. I'll just share my screen to do a quick report of the most recent results. We do have multiple sites on the shoreline of Clear Lake. It's over 100 miles of shoreline. There are also interior of the lake sites that we get samples from when UC Davis is out there, or other partners are out there doing their work, and we'll get water samples from them. These are the most recent results that we have. What we have found is the toxin levels over the summer. We go out every 2 weeks and we get water samples. We do microscopy on all of the samples and send off for toxins based on the dominant genus that we're seeing in the samples. This summer we had Lingbia for quite a while, and Lingbia is a Cylindrospermopsin and Saxitoxin producer. We were having the lab analyze for those toxins, qPCR sometimes, and getting no detect of the genes that produce those toxins. And so we were finding that, sort of this dominant cyanobacteria for August and part of September was not a toxin producer, and the microsystem that we saw in Clear Lake got as high as just in the few hundreds, and that's a big difference from last summer, where we had a microsystem hit of over 160,000 micrograms per liter in the lower arm. So in general, we are seeing better water quality on Clear Lake, fewer dangers for this summer. Which is really surprising because the lake is even lower than it was last year. There's a lot less water in the lake, and the temperatures are quite high. We also continue the private intakes, the self-supplied systems or private drinking water system toxin testing through a CDC grant, and we're partnering with Tracking California. So we have both last year and this year, we're doing toxin as well as other contaminants, microsystem and anatoxin, as well as other contaminants, E. coli and things like that, in the drinking water systems that are pulling from Clear Lake. And we continue to, last year we found a lot more people, I think 60% of the homes that were pulling from the lake had visible cyanobacteria in their tap water, and quite a few of them, a large percentage, great spreading percentage, had toxin levels above the EPA health advisory value of 0.3 micrograms per liter for microsystem and drinking water. So we're continuing that, and we are going to be doing that for another year or so. And I think that was, oh, the other thing is also with that grant, we are doing cyanotoxin monitoring in the creeks. And I've been, with the help of Jamie and others at Squirp and Becky Stanton and others, we have installed spat bags in multiple locations on the creeks in Clear Lake and are working on the communication efforts with the county of Lake and with the state on the results. We'll be continuing some of that for this following year, but we did see with spat bags and also with grab samples, various cyanotoxins in the creeks, including places where people had swimming holes and other human activities. So just expanding to have a better sense of that. And I think that's it for Clear Lake. Any questions? All right, let's move to Region 6, Sabrina.
Good morning, everyone. Can you hear me?
Yes.
Okay. My name's Sabrina Rice. I'm from Lahontan Water Board, and we definitely had a pretty busy season this year. So we also participated in the pre-holiday and post-holiday assessments. We sampled around 30 lakes during those timeframes of the holiday assessments. Some of that included partner monitoring. And then we worked with about 15 different partners. And I thank all of you, if any of you are on the call, you're a great help, making these events go forward. And then we reached 5 danger advisories within our region, within Indian Creek Reservoir, the Tahoe Keys Lagoons, Bridgeport Reservoir, Crowley Lake, and Pleasant Valley Reservoir. And then we also continued our special studies this season at Red Lake and within the Tahoe Keys. At Red Lake, we're sampling, it's in a relatively undisturbed landscape, but it has experienced danger level HABs in the past. So we go out monthly and collect some samples to try to get some insight on HAB trends in the area. And then the Tahoe Keys, we are sampling to see the effectiveness of a non-chemical control measure called a laminar flow aeration system. And that was originally put in place to reduce aquatic invasive species, but we're trying to see if it has any effect on HABs as well. And then in the Tahoe Keys this season, the control methods test began, and that's a 3-year project to evaluate treatment methods to target aquatic invasive weeds. And they used some non-chemical control measures as well as some chemical control measures. So we've actually been going out more often to sample in the Tahoe Keys to see the effect on HABs that project is having as well. And then we had a few suspected illnesses in the area. 2 were in Lake Tahoe, and then 1 at Trout Creek. And then we had a few potential human illnesses that I believe actually have been confirmed that they weren't related to HABs, but they were at Lake Gregory. And that is it.
Thanks, Sabrina. Are there any questions for Sabrina or anyone else in Region 6? Sabrina, I had a question about the non-chemical control to see the effects on HABs. What were you using?
They're using a laminar flow aeration system in the Tahoe Keys. That project's been going on since 2019. And then the Tahoe Keys also uses like UV light treatment. And that one's for aquatic weeds. We're not really studying that one to see its effect on HABs. And I think that's the main usage they have.
Thank you. All right, Region 7, Jeff. I don't see Jeff on here. Is there anyone from Region 7 or Marissa?
Yeah, for Region 7, that's the Colorado Desert Regional Board, including Palm Spring, so that kind of area. So they continued the year-round sampling at the Salton Sea at 3 of the main points of access, and that information is available on the web map. There's a co-occurring, planktonic bloom in the water column, and also algal mats, cyanobacteria dominant algal mats, also along the shoreline and on growing on like the thick crust. It has a little different geology there in Salton Sea. Again, it's a lake that is more salty than the ocean. It's a unique system. They are also sampling on working with Arizona State as well, sampling Lake Havasu and in that area, particularly on the western and eastern sides where there's recreation around some towns, and also some in collaborating with some tribal governments as well, on collecting some information and potentially developing a study for next year in that area. And that's it for that region.
Thank you. That reminds me of, I think Lake Havasu, isn't that one of the lakes with quagga and zebra mussels? Like it's heavily infested with the quagga and zebra mussels, and I know there's been some talk about, or there's some linkage that is being followed on harmful algal blooms and quagga and zebra mussels. At least, or at least in the early years there was.
There's quite a bit of research happening in that area. I'm not sure if somebody wanted to just speak up right now. Go ahead.
It is loaded with quagga mussels. That's where they were first found in California.
Thank you, Bill. We'll look into that further and see if we want to provide an update to CCHAB on that.
Okay, thank you. Okay, so that is Region 7. Region 8, Barbara, Carrie, or Pamela?
This is Marissa. I'll try to speak for them. So this is the Santa Ana region, and they are coming to the end of a 2-year, quite extensive Hab trends and drivers study on Big Bear Lake, a little bit higher up in the elevation in Riverside County, and Lake Elsinore, which is a terminal lake in an urban setting. And the monitoring information was really helpful. We're going to be looking through the data a little bit more thoroughly, of course, this winter, but it also helped with public reporting of incidents and public health complaints that we had monitoring data nearby to inform what the water conditions are. The public health advisories ranged from the lowest level of Hab advisories to the highest. Recently, both lakes have been downgraded to the caution level, which is great to see. We hope to be able to present a little bit of information on the two-year study, perhaps at a future CCHAB meeting. They also coordinated with the holiday assessments, was particularly with some of the regional parks and with some other partner entities to monitor Lake Hemet, and again, many regional parks through the San Bernardino County, which are heavily recreated for swimming and fishing. So that was really great to see that continued effort to provide more information, particularly for the anglers in that area.
Thank you, Marissa. Any questions for Marissa on Region 8?
And most everyone's mentioned these holiday assessments. If we have a moment, I have a slide on that just to provide a recap to all the CCHAB members on what has transpired this summer.
Yeah, why don't we finish with Region 9? And I think there's going to be time. We're definitely moving quickly this morning. So Carrie or someone else from Region 9 would like to present on your report?
Yeah, sure. This is Carrie. So we also participated in the pre-holiday assessments, and in our region, we focused mostly on rivers with swimming holes where we know that people recreate and bring dogs. And then we also sampled at one smaller reservoir that has a children's fishing program. And that's mostly because our larger reservoirs, one, you're not allowed to swim, and two, a lot of the reservoir operators actually have cyanobacteria and cyanotoxins monitoring in their programs. So one, for example, is Lake Henshaw. That lake, it's been our problem child forever, and it's been posted caution the entire year. As far as our assessments, though, we had really good news in our region. During the pre-holiday assessments, we didn't have any sampling that warranted postings. However, one of our sites is a very popular hiking trail called Cedar Creek Falls. We could tell at the 4th of July that a bloom was about to start. And then we had the extreme heat wave and the trail was closed to the public. But as soon as it was open again after Labor Day, we went back to sample, and it's currently at a danger level, unfortunately. So we worked with the Forest Service there to get signs posted as soon as possible. And we are going to do the follow-up monitoring for them once the conditions change and or we get a good rain to see how that changes things. Our other postings that we had were results of complaint responses. So one was the San Dieguito River, and that ended up being posted from June to September at a caution level. The bloom has now dissipated, but it's an unfortunate, occurrence, but fortunate we were able to work with the landowner there, and now they want to do their own routine monitoring in that area, since a lot of people do hike on the trails there and bring dogs. So that was one. And then the other that required sign postings was the San Luis Rey River Estuary, and that empties into the Pacific Ocean when the berm is breached. This year it was not breached, so from August to September we actually had some toxic mats that formed. So it was posted as it was only caution level from that time, and then we had some pretty high wave action, and then the recent rains made the mats dissipate, so it's no longer posted. But that was another good one with the lifeguards there. We're happy to post the signs and asked us for the follow-up monitoring to make sure that it was safe when they could depost. And I think those were our major events this year. Thanks.
Thank you, Carrie. Any questions for Carrie for Region 9? All right, Marissa, please take us through these assessments that were so helpful this year. And we have some extra time, so feel free to go into it.
Okay, do you have like 3 minutes, do you think, or just wanted to...
We are actually about 15 minutes ahead.
Cool, all right. So everyone, this is Marissa Van Dyke. I know I've been speaking along with the co-chairs. I'm just one of the many that make up the Freshwater and Estuarine Harmful Algal Bloom program at the California Water Boards. The Water Boards is a state agency involved in water resources and water quality. We also have 9 regions across the state, and those are regional water boards. And you've been hearing updates from the Hab coordinators in those regions. Just wanted to highlight that a little bit of who we are. And we consist of some full-time Hab coordinators and also some that are kind of borrowed and really appreciated, providing updates. And during these regional updates, any other organization, entity that monitors waterways for harmful algal blooms, you can provide an update as well. So please keep that in mind, even if it's just a brief statement. We appreciate hearing from all these different entities. And this program works collaboratively with many other state agencies, local agencies, federals, and many partner organizations as well.
Thank you, sweetie.
All right.
Please mute your microphone. Thank you.
All right. I'm sorry, I'm not in presentation mode. Since we do have a few moments, I actually will do that. help out there. So we did have just a brief update, just in case there was time during the regional update. So I'll just go through that during this time. Thanks for the opportunity to address everyone. And feel free to ask questions as I go through this material, and including any of our partner organizations and entities. So just briefly, again, the HABS program, it's been around for many years before it was formalized with legislation. We began in 2016. Back then, we were designated the lead agency to start responding to reports of blooms and coordinating incident response. Since that time, much has changed. In 2019, there was an assembly bill that formalized the program and gave us more broad objectives, including comprehensive statewide monitoring, developing risk assessment tools, coordinating data management with other state agencies and entities that respond to blooms as well, and for recreation, drinking water, aquatic life, and so forth. This is just a map of California to show you a little bit more about how we're spread out with resources, particularly staff. Our program has 5 full-time staff, most in Sacramento area, and then in the North Coast area is Michael Thomas. Karen Atkins represents the Central Valley, and also Sabrina Rice in the Wilhanton region. And we also have part-time borrowed staff that are really great and been coordinating lots of the studies as well, or leading the studies in different regions, and they spoke today as well. So thank you, everyone. Our main purpose is to coordinate that instant response with local agencies to assess conditions and post advisors as appropriate. So that's where you're going to be seeing them most often. And on the California House portal, we have contacts for everyone, and including our partner agencies that make this all happen, including our illness work group, an interagency effort with Kelly PA's OWIHA toxicologist, so Becky Stanton and others, and Shannon Murphy. Also, we work with Department of Public Health and also Department of Fish and Wildlife on the illness work group. We're just being brief. I don't have slides for everyone, but thank you. With our main objective of doing incident response and coordination, we also manage the web map that's on the California HABS portal that presents all public complaints or reports, and also reports of proactive monitoring from all of our partner organizations. It's all displayed together on one map. So you need to hover over the dot to see if this was an incident or if it's an update from a routine monitoring program. Next year, we're going to be starting an effort to improve our mapping system and provide separate maps to showcase monitoring data, that proactive monitoring year-round for HABs and other water quality measurements, separate from incident reports. So please stay tuned and feel free to contact us if you're interested in utilizing our web map tools to perhaps replace the map that your organization is hosting, and that kind of thing. We can try to serve all of the as many partners, organizations needs on a single map if we can. This just provides also on the left a brief table of our number of incident reports that we received over the past few years, and it's steadily climbing, unfortunately, and we're it just highlights that we need more resources to continue responding to these incidents and also the illness reports. And this is a plug for the California HABS portal. The website is down below, and much of this information is developed by CCHAB network and member agencies. The Water Board just co-manages this with the co-chairs, this content, and it has the web mapping, including the satellite imagery tool, much information on how to stay safe for public health and also for domestic animals and wildlife. And we also have a summary of the CCHAB guidance for responding to blooms in recreational waters, and the pre-made signs and float charts for planktonic and benthic blooms across the state, and also a field guide that pulls together sampling procedures and other guidance that's necessary for collecting samples and interpreting those results. All right, so we've been talking a lot about these holiday assessments. So this is something that you know, was a need to express from CCHAB network, and we started hosting these along with CCHAB in 2018. First off with the Labor Day weekend, just because there were so many reports that had been escalating that summer. And this is an event where we reach out to partners and use as much resources as we can from the FHAB program to fund sample analysis for toxins and microscopy. So understand a little bit more about the taxa that are present in the more popular recreational waterways. So we can't assess all the waterways, but we try to prioritize those that are used for recreation, including swimming, bathing, and fishing. And since that time, in 2021, was the first time we were able to host these events for all 3 major summer holidays, so Memorial Day weekend, Independence Day, and Labor Day weekends. Though, you know, we do have blooms spanning a little bit larger time frame in some areas, but this is a monitoring effort really to help us get more than one data point, particularly for incident response throughout the year, to start collecting more monitoring data and to be able to provide funding and support, you know, that coordination for follow-up monitoring for areas where there already is a report for posting, and also to show where it is safe. Many of our events, sample sites do showcase green or no advisory, which is awesome to be able to share. This year, we did the 3 events, and also we have some additional funding, which is really rare. We're not going to have it next year, but we were able to fund a more fall assessment that started at the end of September to early October for a sampling event. This was announced in the CCHAB membership listserv. So we'll send that out again just to keep everyone apprised, because for any waterway that is posted from this follow-up event into the fall, we will be having some resources for a November assessment as well. It would be a little bit more truncated. We appreciate all of the efforts from our partners to do the surveys and to collect samples. So thank you very much. And that information is always posted on our web app as the information comes in. Try to get that up as soon as possible. Here's just like snapshots of the web map displaying the information that was collected at that time frame, normally like about Thursday before the holiday weekend. So you can kind of see the distribution across California that we're trying to cover. And we had really great success this year with our partners with collecting many observations at many sites. So Memorial Day assessment, we were able to cover 152 sites. It dropped a little bit in 4th of July. You know, many people are on holiday, we understand. And then we had the most coverage for the Labor Day assessment with 188 sites sampled. And with us, we also get visual observations, which are handy, taxonomy again, and cyanotoxins by Eliza for Microsystems, Cyanotoxin A, Cylindrospermopsin, and Saxitoxin. We're trying to cover the most dominant cyanotoxins detected in California with these events, and try to get non-detect information and detect. So we're not prioritizing a certain toxin like we do with some special studies. And the results from again, the results are always posted to the map and correlated with any advisory or non-advisory. So please take a look. We also have historic information for the year as well. And with our data management or data tool upgrade that's behind this map, by next month, you'll be able to download the entire data set in spreadsheet format behind this map. Sorry, this has not come online yet this summer. Are there any questions? Okay, so this is a little reminder that we've been doing an upgrade. We upgraded our database and reporting system that's behind the map, and it has more functionality than it did before. one of the really cool components of this is that we've partnered with the Commons and Internet of Water. These are nonprofits that support the Water Reporter app. And the connections to the Water Reporter app is coming online. Let's see, do I have any more information? No. So the Water Reporter app, it's tool that's online with these pro accounts that are funded by a grant for any of our partnering organizations. We've been targeting community groups, tribes, and environmental health departments, where you can create stations that you're monitoring, upload any of your field observations, photos, that kind of thing. And in that app, it also has a mapping tool, so you can visualize your information from your organization. And if you're making it shared amongst the community of Water Reporter, you can also see any other monitoring from like neighbors, neighboring areas, and that kind of thing. And it really promotes a collaborative network. And one of the things that we've been working on is being able to ingest the data from Water Reporter app into the Hab programs data system, so that we can review your monitoring information for any incidents, and also display it on our future new revised map that really showcases the statewide monitoring that's being done. So right here, I have a little tiny URL where you can download a fact sheet on the Water Reporter app and how you can get connected if you're interested. So just a couple like announcements. We are required to do yearly reporting to the legislature, and that's coming online soon on our program webpage. We're also working on getting a continuing our laboratory services. So we have a program that we offer for the holiday assessments and initial incident response. We're going to be continuing partnerships with some statewide monitoring programs, particularly the Stream Biological Assessment Program, and working towards monitoring more of the fish bioaccumulation of cyanotoxins, along with the STEW program. We recently distributed durable advisory signs and general awareness signs to over 50 partners through a contract that we have with Squirt. So thank you everyone for your interest on getting signs handy before you need it, or during the summer when you do need it. And sorry about getting those out a little late. There's some supply issues with getting this out. And also you'll be hearing a talk later. It's one of the later talks from Randy Turner of SFEI about improving the functionality of the satellite imagery web tools. So that's remotely sensed information for detecting cyanobacteria abundance in major lakes and reservoirs. And we are also working on adding the remotely sensed chlorophyll data as well this year, so stay tuned. And want to put in some plugs for events. So for some of you who can't travel to the US Hab Symposium, keep in mind there is a one of the days which has really great Hab talks, has a virtual day. So you can have virtual attendance, and it's $50 and you can register online. And also there's going to be a Delta Hab workshop in early November, which was also announced on CCHAB. All right, are there any questions, comments?
Marissa, I want to thank you for that impromptu but very helpful update on the FHAB program. And thank you for filling that space so well. It's always a pleasure to see that information and see the data that's coming from the program. We're going to go ahead and move into a 10-minute break, actually a 9-minute break. So please be back by 10:05 for an update from Dr. Reggie Linville from OEHA. Thank you. We'll be back at 10:05.
Thank you as well.
Becky, if you want to go. I'm sorry, Reggie, if you'd like to go ahead and get started, Becky will be advancing your slides.
Okay, thanks, Sarah. So I am Regina Linville. I am with the Office of Environmental Health Hazard Assessments, and I'm here to talk to you today about notification levels in drinking water for cyanotoxins. Oops. Oh, next slide, please. So California notification levels are non-regulatory health-based advisory levels for chemicals in finished drinking water. They're based on the health and safety code shown here, and they are established for contaminants that do not have maximum contaminant levels in regulation. Public water systems are encouraged to test for the chemical in drinking water, and in some circumstances, they are ordered to test. They must report exceedances to governing boards of their area and to the water board. They are also urged to report the exceedances to their customers. Oh, next slide. Sorry, I keep trying to advance the slide myself. The water board will also establish a response level, which is typically 10 times above the notification level for cancer endpoints. I'm sorry, let me say that again. 10 times above the notification level for non-cancer endpoints and 100 times above the notification level for cancer endpoints. If tested drinking water is above the response level, then the water board can recommend that the water source be removed so it cannot be consumed by customers. Next slide. So if asked, AWEA will recommend a notification level to the Division of Drinking Water at the water board. Next, the DDW establishes the notification and response levels. Then there is an informational item at the State Water Board meeting, and public notices and electronic links are provided to the public. But do note that the cyanotoxin recommended notification levels that we're discussing here today have not been established at this time. Next slide. So here are the recommended notification levels for cyanotoxins. We had developed short-term and acute NLs for 4 cyanotoxins, including anatoxin A, cylindrospermopsin, microsystems, and saxitoxins. The acute NLs represent 1 day of exposure. They are 8 ppb for anatoxin A, 3 for cylindrospermopsin, 3 for microsystems, and 0.5 for saxitoxins. So those are concentrations, those are limits in drinking water. The short-term NLs represent 1 to 3 months of exposure through drinking water. They are 4 ppb for anatoxin A, 0.3 for cylindrospermopsin, 0.03 for microcystin, and there wasn't enough data to derive one for a short term for saxitoxin. So anatoxin A and saxitoxins are based on neurotoxicity effects. Cylindrospermopsin is based on liver and kidney impacts, and microsystems is based on liver damage and a decline in sperm number. Next slide. So to develop a notification level, you first do a literature search, and this slide describes the literature search for the acute effects of microsystems. We identified 269 articles, 226 of which were on humans, but none of those were suitable for deriving a health-based concentration. The remaining 43 papers were on animals, and 4 papers matched our full search criteria. We ended up with 4 studies on acute oral toxicity to consider for the development of a microcystin NL. And each study used mice and showed effects of morbidity or mortality and effects on the liver. Next slide, please. So when we derive notification levels, we choose the study with the highest quality and a low point of departure. For cyanotoxins, we are only looking at the non-cancer effects because we don't have data showing that they cause cancer. The quality of the study is determined with multiple factors: duration of study, type of effect, consistency with other studies, number of subjects, and other factors. And it involves scientific judgment. For example, AWEA does not always choose the study with the lowest POD due to the lower quality of the study or other factors. The evaluation of the candidate studies provides justification for the chosen study. Next slide, please. Once the critical study is chosen, the data is used to derive an acceptable daily dose in people. To do that, we first select a point of departure from the study. This is a dose that generally indicates where the chemical is about to become toxic or is toxic in the observed study. We prefer to base the POD on benchmark dose modeling. BMDL is a model dose from the dose-response relationship of the study that results in a predetermined level of response, such as 5 or 10% above the control for dichotomous data. If that is not available, then we can use the NOEL, the no observed adverse effect level. And if necessary, we can use the LOEL, the lowest observed adverse effect level. So once we have the POD, we determine the appropriate uncertainty factors. So for example, a factor for extrapolating from animals to humans, one for the variability within humans, and for the lack of data, and for other uncertainties. The POD is divided by the combined UFs to get the ADD, which is the estimated maximum daily dose that can be consumed by humans over a period of time without toxic effects. So for acute ADDs, this period is 1 day. Next slide, please. So for microsystems, the critical study for acute effects was Chernoff et al. 2021, because this study had the highest quality and a low POD. The POD, the endpoint is increased liver weight, and the benchmark dose was set at 10% above the control. The BMDL was 1.01 micrograms per kilogram microsystem. The complete uncertainty factor used was 1,000, and it consisted of 10 for extrapolating from mice to humans, 30 for the variation between people, and square root of 10 for a limited toxicity database. By dividing the POD by the uncertainty factor, we calculated the acute acceptable dose for microsystems of 1 × 10⁻³ milligrams per kilogram day in people. Next slide, please. Once we have the ADD in people, we derive a health protective concentration in drinking water, which we will then recommend as the NL. So to do this, we have the ADD. We also apply a relative source contribution to represent the proportion of exposure attributed to tap water as a part of the total exposure from all sources, including food and ambient air. We apply the drinking water intake rate for the most sensitive age group as appropriate. And these parameters are included in the equation shown here. Next slide, please. So for acute exposure to microsystems in drinking water, we have the ADD. For the relative source contribution for acute exposures, we assumed that a large fish or shellfish meal could occur and that it could contain microsystems. So we assigned an RSC of 0.2 to acute drinking water exposure. Now this allows 80% of the acceptable daily dose of microsystems to come from other sources, such as a large fish or shellfish meal. And in this exposure, the age group ingesting the most water is children aged 2 to 16 years. So we use that drinking water intake. So following this equation, the acute health protective concentration for microsystems in drinking water is 3.3 micrograms per liter. And this is recommended as the acute NL for microsystems and rounded to 3 micrograms per liter or parts per billion. Next slide. So the next 2 slides show details of the development of the acute cyanotoxin NLs. The acute anatoxin NL was based on neurotoxicity in mice from a short study by the Falwell et al. 1999 study. The complete uncertainty factor used was 1,000, 10 to extrapolate from mice to humans, 30 for variability between people, and square root of 10 for limited toxicity database. The Salindaspermopsin acute NL is based on liver and kidney cell death in mice from the Bazin et al. 2010 study. The complete uncertainty factor of 1,000 was the same as that was used for anatoxin A. And I just went over the microsystems. The acute Saxitoxin NL was based on neurotoxicity in humans from a paper reviewing 500 case studies of saxitoxin poisonings by EFSA 2009. The complete uncertainty factor for this was 10 and included square root of 10 for extrapolating from low L to no L, and square root of 10 for the most sensitive humans. Next slide. So for every acute cyanotoxin NL, the RSC, the relative source contribution, is set at 0.2 to allow for a large fish or shellfish meal containing the cyanotoxin within 24 hours. The drinking water intake is based on a child, 2 to 16-year-old, and the acute NLs again are 8 parts per billion for anatoxin, 3 for cylindospermopsin, 3 for microcystin, and 0.5 for saxitoxin. That's in ppb. That is the exposure for 1 day in drinking water. So next slide, please. So we also developed short-term recommended NLs for anatoxin A, cylindospermopsin, and microcystin. I'm going to go through the development of short-term microcystin NL as an example. So an important note here is that the recommended microsystems and cylindospermopsin NL for short-term exposure is interim. When developing these notification levels, we did not have time to go through a complete literature review. So instead, we selected an interim critical study from those used by other government agencies, including the WHO, US EPA, and France. This gave us these 3 toxicity studies in microcystin, and the Fawell et al. And Hines study had liver endpoints, and the Chen et al. Study had the more sensitive reproductive endpoints on sperm. Next slide, please. So we selected the critical study of Chen et al. 2011. This study was used by the French Agency for Food, Environmental, and Occupational Health and Safety in a 2019 document, and it was used to develop a subchronic toxicity reference value. So Chen et al. Had the most sensitive endpoints: decline in sperm number, decline in sperm motility, and increase in abnormal sperm. So these endpoints are supported by several other studies. And again, this is an interim NL. Numerous recently published studies were identified and will be reviewed in the development of the final NL recommendation. Next slide, please. So the POD of Chen et al. Was set to the BMDL of 0.1786 micrograms per kilogram per day, and it was for the endpoint of sperm decline. We applied a complete uncertainty factor of 100, 10 to extrapolate from rodents to humans, 10 to account for variability between humans, and this is typically 30 at a WEHA, but we lowered it by square root of 10 because sperm decline is not relevant to prepubescent children. And we did not include a UF for database deficiencies because several studies supported this critical study and the endpoint is sensitive. So the short-term ADD of 1.8 times 10 to the negative 6 milligrams per kilogram per day was derived for short-term microsystems. Next slide, please. So the relative source contribution was 1 because tap water was anticipated as the only source of exposure to microsystems. But further analysis is ongoing to determine the final RSC. We applied a lifetime average drinking water intake rate, and we did not use the drinking water intake rate for formula-fed infants because the impact of sperm decline is not relevant to that subpopulation. The health protective concentration is 0.034 micrograms per liter in drinking water. And this level is recommended as a short-term notification level for microsystems at 0.03 parts per billion. Next slide. So the next two slides show the details of the development of all short-term cyanotoxin NLs. The short-term anatoxin NL is based on neurotoxicity in mice from the Falwell 1999 study. The uncertainty factor was 3,000 and included 10 for extrapolating from mice to humans, 30 to account for variability between humans, and 10 for a very limited toxicity database. And the anatoxin A NL for the short-term exposure is a final NL. The cylindrospermopsin short-term NL was based on liver damage in mice from the Chernoff et al. 2018 study. The uncertainty factor was 1,000 and included 10 for extrapolating from mice to humans, 30 to account for variability between humans, and square root of 10 for database deficiencies. So I just went over the microsystem short-term NL, and for saxitoxin, we didn't have enough data to do a short-term NL on this cyanotoxin. Next slide, please. So for anatoxin, the exposure is based on a formula-fed infant and the drinking water of that infant, the drinking water intake rate for that infant. So a formula-fed infant would not be expected to receive significant amounts of anatoxin from other sources. So the RSC is 1, and the short-term NL is 4 parts per billion. For cylindrospermopsin, the exposure is based on an average person ingesting a lifetime average drinking water intake rate. We applied a relative source contribution of 1. We're reviewing this for the final NL, and the interim short-term NL is 0.3 parts per billion. And again, the microsystem was just discussed, and we didn't have data for saxitoxin short-term. Next slide, please. So once these notifications are established by the water board, there will be 3 final and 1 interim acute notification level for 1 day of exposure, and 1 final and 2 interim short-term notification levels for 1 month to 3 months of exposure. AWEA has started working to develop the final notification levels to replace the interims. However, there is not a projected finish date yet for these. So next slide. So that is my talk, and I'm ready for questions if you have any.
Thank you so much. Sue.
Great. Thank you, Reggie. That was wonderful. Question for you about the short-term microsystem NL.
Yeah.
How does that compare to the typical limit of detection that we use in our different analytical methods for drinking water?
Well, it can be detected, but I am not the best person to talk about the regular use of that analytical methods in drinking water, but we did make sure that using MS tandem that you can detect that low of a concentration.
Great, thank you.
And Sue, I'll just add for the CalWatch study, I think we had some, Sarah, correct me if I'm wrong, some of the results from CDPH lab with LCMS, MS that were in that range as far as a sum. So
yes,
just validating what Reggie just said on a practical study.
Great, but are any of you aware of the limit of detection for the EPA drinking water Eliza analysis? Limit of detection?
Yes.
0.15.
That's right. So this is Marissa, it's 0.15 for a limited detection, and then the reporting level is 0.3.
Great, thank you. So any detect by that would trigger the notification level.
Yeah, and to repeat, that's EPA method 546 that uses Eliza kits to analyze for total microsystems.
Other questions for Reggie? But Reggie, I guess I have a question on saxitoxin. We're starting to, we have some saxitoxin detects in Clear Lake, and just wondering what is it, what does it take to, you know, start to say we have enough data to be able to use to further develop notification levels? Like, it's obviously health data, but if we're starting to have detects in water body in terms of ambient monitoring, what else? Can you talk about that?
Yeah.
Like, what else would you need to see?
So for the notification levels, we're only testing drinking water. We're not testing source water. So, and you know, I can't say what the water board will say as far as how many samples are needed to report, or if they're going to say any samples. Saxitoxin is an acute notification level, so it could be that, you know, one measurement is for that day, you know, and that if you have one measurement in your drinking water plant over, then you're over the notification level. And the same for the response level, and then the water board could suggest that that source is removed. So as far as the source water for drinking water, no, these do not apply to that.
But I guess what one could do is, if you're seeing it in the source water, then might want to do the monitoring in the, or the analysis in the tap water in the finished.
Yeah, that would be good.
Sue?
Thank you. I just wanted to ask a couple follow-up questions. Is there any sense of timing about when this will be considered by the water boards? And will it apply to all drinking water sources, both the private ones that fall below the regulation level that the Cal Watch is looking at?
So I'm sorry, I don't know the answer to either of those. We are not clear on the timeline for the water board, or at least I'm not. My branch manager might be, but sorry. Geez, I'm sorry. Can you repeat your second question?
I was just wondering if, you know, different agencies regulate drinking water at different levels. And I'm wondering if private domestic water supplies or small, very, very small groups, like maybe 3 or 4 houses that share a source water, would be subject to this, or could comply with it.
So the answer is I really am not sure, but I do believe that they would not be. I think this is for public drinking water sources, but you'd have to ask the water board to confirm that.
Okay, thank you.
Thanks.
I mean, I would like to say, in terms of the monitoring that is happening out here for the private systems, that, you know, cyanotoxins obviously is not a primary standard with the Safe Drinking Water Act. So those, of course, aren't even necessary to monitor for those, not required. And certainly the private systems that have 1 to 4 service connections are not, there's no monitoring that they have to do to meet the Safe Drinking Water Act. The state smalls that have 5 to 14 service connections do have some monitoring that they've got to do, but you know, well, until cyanotoxins becomes a primary contaminant and a primary standard in the Safe Drinking Water Act, where you can't move forward with mandatory, obviously, and these small ones, I don't know if those would ever be regulated.
But at least the numbers are there. If these numbers are established, at least they're there. So a small group, if they got a level, they would have some information on how to interpret it.
Marissa, I wasn't able to raise my hand. The tool's not working. I have a
Hi, Marissa.
question.
Go ahead.
I know that we've been, some of you have asked what the water board's plans are and timelines. Though working at the water boards, I have not heard of a timeline from the Division of Drinking Water. So we will request that again of them, and perhaps we'll have an update at the next CCHAB meeting. I really hope that we will have an update. This is great information, and thank you to Reggie and Becky for presenting it.
Thanks.
Thank you. Thank you, Reggie. We're going to go ahead and move to the presentation from Dr. Karen McLaughlin, the BITE Regional Hab Monitoring Program, the 940 agenda item. So Dr. McLaughlin, if you'd like to share your screen and get us started with that. And thank you for your flexibility. And I'm sorry about the agenda switch.
No problem. Can you guys hear me?
Yes.
Excellent. Okay. So thank you guys for having me here. I'm here to talk about the Southern California BITE 2023 Regional Monitoring Program that we're hoping to launch next summer. So for those of you who are uninitiated, you might want to know what the BITE program is. The BITE program is an integrated, coordinated monitoring program, which is designed to answer basic questions about environmental status and trends not captured any other way. And that integrated, coordinated part, that is the collaborative piece. And that's why I'm here talking to you guys today, because the goal of the program is to bring together everyone that does sort of localized monitoring or monitoring of a specific type together to get these unified assessments of the quality or the status of the Southern California BITE as a whole using multiple indicators. And the goal here is to focus on current management needs and to document the success of management actions. So the program has a 5-year planning cycle, which is what we're in the beginning of the next one right now. So we're trying to develop what our management needs are to try to develop studies that can actually help address them. So for some folks in the BITE program, it's a regulatory mandate. So we have this sort of base level support that keeps the program going. You basically get regulatory relief to participate in the BITE program as a part of your NPDES programs in the Southern California region. But it's more than that. So the BITE program brings in academic partners and NGOs, all kinds of different groups to build on this base level of support to explore new problems and look at new needs and emerging concerns. This is not our first rodeo. This is our 7th survey. The BITE program actually started in 1994, and the figure on the right here is what it looked like in 1994. It was just a coastal transect looking at sediment quality as an integrator for human impacts on the coastal zone. But since then, it has grown significantly. You can see all the sites that we've sampled between 1994 and 1998. The yellow dots are the BITE program sites, and the blue dots are the other regional program that's facilitated by SWRP, the Stormwater Monitoring Coalition stream survey. And those programs kind of work together to get a regional picture of what's going on in Southern California watersheds and coastal zone. So we're growing each year, adding new elements, and we're excited to see what's happening in 2023. The program is a national model, and the reason it is so successful and it has had such a longevity is because of this collaboration and communication. So the program is designed with science to support managers. So the managers are involved from the very beginning, telling us what their needs are and developing the study design with the scientists and the monitoring groups to try to address the questions that help serve this science to management transition. There's this need, so it has this ability to evolve that's kept the program so fresh. The BITE program has a number of values, and if you're not like on board right now, maybe this slide will help bring you all the way on board. But they basically fall into 3 main categories. And the first one is sort of providing a consensus assessment that no single agency can alone. So everyone's out there doing their monitoring, but the BITE program brings everyone together. We do everything the same way, so all the data is intercalibrated and comparable, which provides a benefit to our partners because now you have independent QA/QC of your own programs, and you have this training and auditing that elevates everybody up to the highest standards. And because we have multiple elements, we're providing a cumulative impact assessment. So we're not just looking at HABs, right? We're looking at HABs and contaminants of emerging concern and climate change, all these different things, we can pull them all together to try to get a bigger picture of what's going on. And this focus on the management needs and the document of success, that's what makes it relevant to the managers. It's why people keep coming back. So it helps us develop new indicators and assessment tools and help with the listing and delisting of water bodies on our coast. And it's also a wonderful opportunity to try new things outside of permit requirements. So most people are kind of stuck in their permit requirements. They can't really do much outside of that. But the BITE program actually lets us break new ground. It helps us explore habitats that are outside of those permits, try new methods, validate those new methods against existing methods, and try new technologies which can help advance monitoring as a science, looking at what can make monitoring better, faster, and cheaper. So the BITE 2023 program, I told you, is not just HAB, so I'm not going to go through all of these elements, but if you have questions, I do have slides on them if you want to know a little bit more. But the 7 elements that are moving forward are sediment quality, harmful algal blooms, which is most relevant to this group, trash with a microplastics component, microbiology, which is looking at pathogens primarily, and human fecal contamination on beaches, an estuarine condition assessment. So this is an overall condition assessment of Southern California estuaries, a submerged aquatic vegetation group, which is going to look primarily at the condition of eelgrass beds throughout Southern California coast, and a water quality, which is primarily interested in the sort of broad changes in ocean acidification and hypoxia that are affecting the offshore area. What I will also note is that while we have these sort of 7 elements, that 4 of them are kind of coming together in a regional shellfish survey. So we're looking at multiple lines of evidence, looking at impacts on shellfish survey, and HABs is one of those. So for the rest of my time here today, I'm just going to talk primarily about the harmful algal blooms element, as well as this regional shellfish survey, because I think it has the most intersection with this group. But again, if you do have questions on any of these other ones, I'm happy to answer them at the end of the talk. So most relevant to you all is the harmful algal blooms, and I told you that it's intersecting with the shellfish, and that's this first question, which is trying to investigate the extent and magnitude of cyanotoxins that are present in coastal shellfish. So this will look at shellfish both right near river mouths, like within estuaries, but also along coasts where we don't have open interaction with the land-sea interface. There were also a couple of questions that we're interested in addressing that follow on from work that we did during the BITE 18 survey. So looking at long-term trends in domoic acid presence and concentrations in marine sediments. The BITE 18 program actually looked at sediment concentrations of domoic acid, and we found that it was actually pretty prevalent throughout the region, even though we didn't have a large Sediments bloom during the previous spring. So we knew that it's a little bit persistent in our sediments, and we wanted to sort of look more longer term, trying to incorporate that into some of the work that we do as a part of the BITE program, looking at it over time, and also looking to see if it's biomagnifying in the food web. So we looked a little bit about transfer from sediments into some of the benthic infauna, but now we're sort of interested in seeing whether or not it makes it into trawl caught species like the megainvertebrates and demersal fish populations. And then there was also a generic question around looking at extent and magnitude of HABs taxa. So looking at using IFCBs to collect water from our nearshore, inshore, and offshore environments, and trying to start to catalog the HABs taxa that occur in the Southern California BITE, so that we can sort of work towards like a risk assessment model for HABs along the coast. So digging a little bit deeper into the regional shellfish survey. So the question here is our shellfish safe to eat? And this was a primary concern from a number of our water boards, regional water boards in Southern California, as well as a number of our MS4 agencies. So that's where this one is kind of coming from. And they're interested not just in HABs toxins, but they're also interested in a number of different stressors on coastal shellfish, or especially the recreational and commercially fished shellfish beds. So the thought here is to look at legacy contaminants, which would be contributions from the sediment quality group. So they would look at things like DDTs and PBDEs and PCBs, like all the sort of common ones that we look at during our sediment quality assessment, as well as looking at some of the contaminants of emerging concern things like PFAS and tire wear compounds. There's also an interest in looking at microplastics, which is sometimes categorized as a CEC, but it has its own breakout group for the BITE program in the trash. So looking at microplastic presence in shellfish, as well as the Hab toxins, looking primarily at cyanotoxins, although if we can find partners, we might be interested in expanding beyond cyanotoxins, as well as pathogens like norovirus, and there was some thought about looking at vibrios in the shellfish as well. That would be the main human impact. In terms of the planning process, so if you're interested in sort of these two HABs related elements and you want to join on, we are beginning the BITE planning process right now. So we had our kickoff meeting on September 22nd, and now the planning committee groups for each of the elements that I sort of outlined in the previous slide are starting to begin their study design and effort inventory. So there is no dedicated funding for the BITE program. The BITE is run by the people who participate in it. So we sort of match the study design to the people that are in the room during the planning meeting and what they can offer to help us run the program. So it often looks like in-kind support where people volunteer either lab efforts for analysis of things like toxins, or field effort, people who want to go out and collect shellfish, and we try to pull all those resources together to create an effective study design that's aimed at answering the monitoring questions. If we don't have enough effort to address the monitoring question, it kind of dies, because then we know that it's not a high priority for folks in Southern California. They want to prioritize other things. So the next few meetings in the planning committees is going to focus around matching study design to the effort inventory. And then once we have a study design, we'll build our work plans and our quality assurance plans. Then we'll move on to method evaluation and quality control, as well as training all the groups that are going to be doing field collections and sample analysis, doing intercalibrations to make sure the labs are standardized, and conducting those audits to make sure that everyone's following the QA/QC protocols. Then we'll have an information, at the same time kind of working on information management to make sure that the data is accessible on the back end, and then we'll launch the program. And in terms of timeline, that's how this looks. We're developing the questions now through the end of the month in early November, developing our study design and effort inventory through the end of this year, and then working on the work plan and quality assurance protocol plan through the early spring, and then trying to get that standardization and information management settled before we launch, which can be anywhere in sort of the June timeframe. So if you're excited about what I've just told you today, how do you want to get involved? Again, BITE is a collaborative program, and this integration among participants is a fundamental part of that. So we're always looking for partners, because the more partners we have, the more we can do, because effort comes from all of our participants that help build the study designs that can actually make a statistically significant statement about condition. So effort comes in many forms. Most people generate or donate in-kind support, so that's either field or lab efforts, although we do take financial support, that helps us fill in the gaps. So if you have some money lying around and you want to contribute it to the BITE program, we're glad to take it, and that helps us add on additional analytes or get additional sites with consultants, with some of the by funding consultants, to try to hit them so that we can actually get a regional survey. I'm not requiring anything hard from anybody at this point. We're sort of still in the gauging interest time period, but we will need hard commitments by the end of the year. So if you are interested in the BITE program, give me a call, send me an email. We can chat about what you can contribute, and try to get you involved early on so that you can start to be a part of the process. So if you are interested in joining, the first thing you want to do is sign up for a planning committee, and you can do that by emailing me, and I can put you on the email lists that will get you on the notifications for those planning meetings. In the interim, you can sort of figure out how much effort you can and want to contribute, and who among your staff can be participants, and then join the committees. And we'll be meeting probably monthly for the next quarter, trying to get these study designs and efforts nailed down so that we can start building our work plan. And with that, I'm happy to take any questions, or if you want to hear anything about some of the other BITE elements, I'm happy to answer questions about those as well.
Karen, you got some questions in the chat that I can maybe help you with as well. But Sue Keidel had already started with asking about what our focal toxins would be. And I let her know, the initial interest is in the freshwater toxins, given some of the previous work. And then we've got some methodology questions about what we would plan to use, which I'll take that for you if you want.
Yeah, go for it.
Yeah.
So for what it's worth, Jamie Smith is our lead for the BITE HABs program, and she'll be coordinating with the other elements on the shellfish study.
Yeah. So between Karen and I are tag teaming on this project for sure. But I think that right now we're potentially planning on LCMS. We did some pilot work in 2018 using Eliza, and it's challenging to do Eliza on these tissues, especially depending on, we're still in the planning committee phase. So there seems like there's some types of shellfish that work better on Eliza than others when it comes to matrix effects. So that's kind of like a TBD, but we're leaning towards analytical kind of LCMS. And then Catherine Carter asked, is this focusing on Southern California only or the entire coast? I don't know, Karen, if you wanted to.
So the initial focus of the BITE program is Southern California, but we do like to partner with the rest of the state or even the entire West Coast, depending on interest. So for example, we partnered with the Bioaccumulation Oversight Group, which is now STU, I think, the swamp funded fish survey on a bioaccumulation study where we did some additional effort in the Southern California BITE and contributed to that study. And for ocean acidification and hypoxia, that we tend to coordinate with the NOAA West Coast surveys wherever possible as well. So there's definitely opportunities to partner with the rest of the coast and the state of California. So if you are doing a shellfish survey or if you have interest in shellfish in Northern California, we would love to hear about it, because I think the greater the reach of the survey, the more impactful it is to managers in Southern California, because then it helps provide even a greater context for the data that we're collecting. So please reach out to Jamie and myself if you have interest in anything that you've heard today and sort of mimicking that or contributing questions that might also be relevant to Southern California, so that we can start to work a little bit more closely with our Northern Coast partners.
Other questions?
Oh, hi, Jamie. This is Carrie. I just posted a question regarding the two analytical methods. And the reason I posted the question is, as you know, that with both methods, there are definitely pros and cons. And this relates actually back to the notification level and how our samples going to be monitored and how our data going to be interpreted. Because as we have seen, both methods need to be really carefully evaluated, and the results interpretation, we just need to be really careful noticing the potential biases that comes with either of the two methods.
Definitely, yeah. The methods on this is definitely, again, we tried to do this in 2018 and actually kind of paused because the methods were, I feel like we know a little bit more about methods now, but yes, definitely the methods are going to be the hard part of it.
Okay, all right, thank you.
And this is Becky Stanton. Are the results going to be done in a reasonably time efficient manner and then conveyed to the county and the health agencies? I mean, is it going to be a relatively near term response, or is this more under the research, months after the fact kind of situation?
It sort of depends a little bit on the program, right? So the BITE program moves as fast as its slowest participant. So if there's a laboratory that is sort of slow in getting data back, then the effort for the report writing obviously then follows that. So if we have labs that are interested and dedicated to getting the program out in a timely fashion, SQURP matches that rate. So some things like toxicity, that they come out really fast. They come out within a year of the survey. Other programs like the benthic infauna survey, those take a lot longer because they tend not to be the highest priority for some of the participating labs. So they can take years. Most programs tend to get done within a year or two of sample collection at the latest. And that would be 2 years would kind of be a slow for an average type program. So we do try to get them out fast because we know that this is important to managers. Managers are fronting the money for a lot of the effort. So we do try to be timely in getting the results out.
Yeah, but definitely not on the same pace as, say, CDPH. We're not turning these around in like 2 weeks, for example.
No.
So a year is not going to be relevant for a health advisory, I guess, is the bottom line for what I was getting at. It may be fast for you, but it's not fast for what we would be looking at.
No. Yeah. Other questions or comments?
Well, I know we have another speaker queued up for 10:50. I know the timing all got a little bit skewed today, but thanks for Karen for your patience.
And again, no worries. Feel free to contact me if you have any other questions. And I'm happy to talk about bite all day long.
Thanks,
Karen.
Thanks, Karen.
And Dr. Ruth Shumka and we have Duncan, Scott Duncan. Are you guys planning on presenting your slides directly?
Hi. Yeah. Let me see if I can share.
Looks there. Perfect. Thank you.
Is this the correct one?
Yes.
Okay. I'm not sure. Is Scott here? Yes, Scott is here. Okay.
Oh, hi, everybody. I'm here to, Veronica's really presenting, and just in case there are some questions or things, I'm here to help answer questions. So thank you.
Yeah.
I'll mostly be in the background, but if you have a question, I'll be here.
Okay, well, thank you very much for inviting us. I am a postdoc fellow at Harbor Branch in Florida, in Central Florida. And we were told to talk to you a little bit about our experience with the NAF2 sailboat for our harmful algal bloom monitoring project in Lake Okeechobee. And so this is an effort that we got funding to do this for an entire year, and we collected a bunch of data through 2021, the entirety of that. And so with me, it's here also Scott. Scott, it's the president and founder of NavOcean Inc. And so they are the folks that custom built the NAF2 sailboat that we call Dila for this project. And I'm going to be talking a little bit more about what this sailboat is, what are their capabilities, and what we have done with the data collection. And so, and then NavOcean folks built this boat and operated it during the entirety of the project. And so if there are questions more regarding about the operations of the boat and the sensor, he will be here to answer that. And then I also have here in my list Jordan Beckler. He's my advisor here at Harbor Branch, and basically he is the PI of this big project, which was took a little bit more. This was only a component of that. And so just to make recognize our funding, this was funded by the Florida Department of Environmental Protection. And we had a bunch of institutions working for this, but for this part, I also want to recognize the contribution of GCUS, which is the IOS that was helping us to distribute the data. So here, there is a satellite image from Sentinel-2 of Lake Okeechobee during that period. This is actually the best image of the entire year. And the folks that were working with satellite images will know, this is not so common. So this is like one of the most, by far the most clear image of the entire year that we got. And you can see a pretty wide bloom extended in there. But in general, a few words about that, and I kind of made a zoom to just one section of that. So you can see that there is like a lot of structure, a lot of patterns inside of that. It's not just like a green path. And so a few words about like chubby and algal blooms in there. I will go very quickly about that because my understanding is that all here are HABs people, so we don't need too much introduction. But some particularities about this site is this is a pretty large ecosystem, and so it is very difficult to sample. You will not cover the entirety of it in a boat with a panel on a boat. There's no way. It's too big. It's shallow. And there are frequently wind events and that can resuspend sediments. And that is basically our main interest in that. And what is the contribution of the resuspension of the nutrients entrained in the sediments in that environment. It's very turbid. And this will play a role in measurements, as we'll see later. It's eutrophic. And there are frequent algal blooms, and the most predominant species is Microsystems, which is a cyanobacteria, and is a very particular species that is very, very buoyant. So when you see it, it's like this like really green, bright color, and it's very buoyant. It's like so when you touch the water, you see how they kind of like float away. So it's kind of like difficult to sample that correctly. And there's a lot of interest in that because it's not only the health of the lake, that there have been issues on the lake and there have been like pets dying or like a toxicity in the air about that, but also it impacts because of regular discharges of the lake, it impacts other estuaries on both sides of Florida. And so because of that, we were funded to deploy several technologies, and we got to test several technologies about that. And VL was one of them, but we got also to test several technologies to, for instance, monitor sediment, fluxes from the sediments, continuous monitoring of the water column. We also got like to look a little bit more in algorithms for remote sensing and stuff like that. But here I'm going to be talking exclusively about these sailboat measurements. And so there are some particularities about why this is a good idea. This sailboat is small, it is lightweight, and it's not hazardous for small boat traffic. So it allows for a long-term operation, autonomous operations about 2 meters high, 45 kilograms. It will reach 1 to 3 knots depending on navigation. And so there are a couple of pictures here that you see. You can deploy it from a boat, and you can deploy it from the beach. It is built to withstand really heavy weather conditions, as you can see in a picture over here. So it doesn't matter. It can plow through like rain and storms and tornadoes. I'm not sure hurricanes, but it can withstand pretty harsh conditions. And it has real time data transmit capabilities through Iridium or cellular network. And aside of that, it has a data logger on board that stores high frequency measurements. So it was custom built, and here's like a scheme of how it looks like and all the sensors that it was charged with. We have here, for instance, at the top we have like an air max sensor for wind and air temperature, etc. Of course, there are some navigation things like a white light for traffic and navigation, the AIS tracking system for that. And on the top of the school, you have the solar panels on top of here, and then you have like the antenna for transmission of data, and then at the bottom are the sensors, and like all the fluorometric sensors on the front, the backscatter and the fluorometer and the oxygen there. And it was also coupled with the ADCP for 3 bands measurement and typical CT. And as you can see here, it's also equipped with a thruster. So the sailboat will sail with wind, but in cases where it has to like navigate against like strong winds or currents, or when winds are too still, it can be helped also with a thruster. The particular thing that I want to point here is that so you kind of like program on how frequently you want to get this data, and for us it was 1 measurement per second for all the sensor, 1 measurement per second, a cycle for 5 seconds, and then 25 seconds off. So 1, 2, 3, 4, 5, and then 25 seconds off, and then again. And in this sense, it also transmitted every 15 minutes through Iridium to the server, and that data went directly to a web portal that was managed by GCOS. And so here are a picture of how it looks like from the top. Here you can see the solar panel. Here's the GPS, and then at the bottom you can see like the housings of the different sensors and how it looks like. And so thinking about when we were deploying, it's like what things for our specific needs we needed to consider about that. So it was thought that it will basically navigate on its own. And so what things that you have to think about when it will be unattended for long terms. So some concerns we had with lightning storms. Okeechobee is kind of in the middle of the peninsula. There are frequent storms in there, so like having a lightning falling on that was a concern. It never happened, so it's something that we were looking with. We also thought about, well, Florida, alligators. What will be the impact of these little things? Not so little. What will be the reaction towards something moving in the environment? And of course, vessel collision. And this last part it had to do a lot with community engagement and like communication with the public. And this is an excellent work that the NavOcean folks did. And we were like really, really lucky, and we were very successful in this. So we didn't have any issues at all with this. And as people leaving equipment in the field are aware of, like they're always concerns about like accidents or even vandalism. We have no issue at all. It had to do a lot with how it was communicated. It was registered our activities with the Coast Guard, and there was a local notice, and law enforcement was informed. There were several press releases, and the NavOcean folks always took the time to talk with the people on the place. And so these people became like they were interested, and they became very, very interested in what we were doing and what will be the impact. And so they became their own ambassadors and telling others and how what this boat was, and so to keep an eye on it and to keep it safe. So we were really, really lucky, and we have no issues at all during the entire year of operation. And so the operation was literally an entire year. It was deployed on December 31st on New Eve of 2020. And the last day that it operated was January 1st, 2022. So it operated a total of 287 days in separate missions, because even it's autonomous, it still requires some servicing. And so those missions typically last about 2 weeks each, depending. It'll change a little bit of the according to the requirement. We always launch it, almost always launch it and landed it on the north side of the lake in the same spot. And I will show this next. We chose to do our triangular path that it was kind of like the main path the sailboat will follow, and that way we kind of thought that it will approach a sampling transit always from the same direction for data comparison things. And every time that the sailboat was serviced, we had to clean the sensors. We performed a satin ice validation check, and I will talk a little bit about that, what it means and why it was important. The battery was charged. It operated with wind and solar power, but still it requires some instrumentation. So there was a battery on board. Then all the data was downloaded in between missions. And usually we will relaunch the boat in 24 to 48 hours, depending on things. So it was a very efficient process, and because there were other things going on, and other as part of the project, we went all over the field several times and collected samples for validation. And again, the data was transmitted in near real time towards the GICUS process. So that video you saw was like Villa sailing for the first time, and this is the picture of Villa coming back for the last time on January 1st. So here I'm showing you an example of the path that Villa took, and I will show it better in the next slide. But here's a little bit so you have an idea of how much Villa could cover in a day. And so every one of these snapshots that you see are a day of sampling of that. And here I'm showing you chlorophyll just for an idea. So you can see it's not always the same. It doesn't always cover the same extent, because it will depend a little bit on the wind conditions and things like that, and the light conditions. So it will vary, but you can see like the general the structure of the loop. And so the good thing about that was that we could react. And so whenever there was like something interesting, I will say, to react to, we could like redirect the boat to sample in there to see what was going on, and because you could access it directly through the portal or visually or the Navocean server, we could see what was happening. And so here are some examples of that. So for instance, there's a bloom at Taylor Creek that was reported, and we could go and take some samples to see what it was. And here you can see like the path that the boat covered, and it had like pretty elevated chlorophyll signal. As you can see, the phycocyanin and chlorophyll signal here, the phycocyanin to chlorophyll ratio here was pretty constant, and it was everywhere. And so when we went to the field, we saw this kind of like greenish water. We saw this dominant taxa in there that was populating that. Other situations look pretty different. This is a different mission that was out of the loop, and you can see here a little track in there. And here you can see a totally different distribution of phycocyanin to chlorophyll ratio. And you can see that it's pretty patchy, and we found out that usually it's a good indicator of what population can be, like from the color of the water. And so when we went looking in there, you can see how like the strong gradients, the contrast in the water, and how it is seen, and what's the variability that is actually being captured by that. Anyway, as you can see, yes, those are paths, and so like how will you like represent this kind of data over a path in a place that it's moving? And let's kind of like try to visualize what does that mean when you have like a moving time series. What does it mean? And so here is on the left, there is a map of a pretty well monitored Lake Okeechobee. And so all these dots that you see here are stations that are frequently monitored by the Florida Department of Environmental Protection. And some of them have continuous monitoring sensors, and some of them are just like water sample grabs stations that they will go every 2 weeks or so. And so here on top you see like these results from the chlorophyll. Again, I'm just using chlorophyll as an example of a period, say between July and October. Of those results, and here you have like the different sample grabs, and at the same time in the next column, and all this is in this station. This is one of the most monitored stations that it has plenty of sensors on it, so we use it a lot for comparison and validation. So we also installed here a continuous monitoring sensor. It was a sensor at the surface and one at the bottom, and so this is the chlorophyll record from a fluorometer at the surface. And there are a couple of things that I want to point out here. First of all, like, yes, you see all this extreme variability that are of course missed by weekly samples. That is one thing. So you see there are a lot of things going on that you don't capture with this method. But I also want to point out the difference in the measurements on that. And again, this is a fluorometer, this is real life. And so people who work with fluorometers kind of like know that fluorometers are a difficult thing to interpret. And calibrating a fluorometer in the lab doesn't necessarily yield you the best results in the field. But then let's contrast this from what we can capture in a transect. And so here I'm going to show you data from like this transect from this point to like one of the vertices of the triangle. And so this is what a mobile time series looks like. So again, we have time in the x-axis, and then we have the latitude or here in the y-axis. So here on top will correspond to the samples of the continuous monitoring station here on top, and here at the bottom corresponds to this point in here. And so, yeah, you can see these extreme peaks in when they appear in here, and the units, I have not even put the same units because it's totally different. Different fluorometers will indicate the totally different units, even if you calibrate them. But you can see, yes, there is a bunch of variability on top of here because normally it is the north part of the lake that has the highest blooms. And of course, like less in the middle of the lake, you will have a little bit less. But you can see that there is quite a lot of stuff also happening in the middle. And so how do you represent that variability in time? So I want to, the other day I was like looking at this image and it kind of like, we were thinking about like, how do you represent this two-dimensional variability when you just have like one point or in time, or you just have one path? And so what does it mean when you go and grab a sample and you represent that sample as your pattern? How do you capture the small patterns, and how you, because that small patterns account for a variability that has to be associated with your measurement when you report a measurement. So the ASV has these advantages that will cover a very large area, and it has high temporal resolution. And here you can see an overlay of like that Sentinel-2 image with the villa traveling at that time, at the time of that image collection. And you see all these like different, well, call them scums, but I don't really know how to call them. But these are patches of things, and you can really clearly see it represented in the chlorophyll track of villa. But there are constraints too, there are challenges. It is a space-time composite. So how do you decompose those things? How do you decompose the time effect from the space effect? And again, you are using a fluorometer in a very, very, very turbid environment, and that turbidity will affect your measurements. So just as a comparison of 3 different fluorometers in that field. So here at the bottom, we have the DEP fluorometer in the L001 station that I showed you. These are kind of like cheap fluorometers that can be located at the top of the bottom. And then we have our project fluorometer placed kind of like in the same tower on the other leg of the tower. And so you can see the variability in here. And then on top, have collected only the samples that Villa captured within 1 kilometer of the radius when it was within 1 kilometer of the tower. And you can see that, yeah, definitely it had like similar patterns. So you can see like that elevation and stuff, but you can see also like quite a big variability in that and what is happening in there. And how do you compare that? So, but when you look at the entire time series of that, of that entire period, you can see like, yes, so like if you kind of squint your eyes, you see that blob, but in between them, you see all these other things. And so these data filtered, kind of address these now. So those are mean filters for 15 minutes, 1 hour, 1 day, 3 days. So it's kind of like a cumulative means to compare data. And so while you see that this went over here, like if you just look at the local data, all these very big peaks over here, these are not day-night cycles that we will expect normally in a cycle like that, because you don't see that in the continuous monitoring. But these are the spatial structure. So we have things in this mobile time series that take like about half a day or something to cross. So it is difficult to detach those things. So let's talk very quickly about strategies on how we can approach this and how we can explore this data for that. And for that, I'm going to be focusing only on one transect because of time. And so I'm going to show you what we found out about this particular transect of the loop, that I call it the coastal transect because it's kind of like closer like that. So what I did was construct a geofence over here and project the line, and then project all the data captured in here towards the line and kind of like see how that varies over time. And so here is a plot of that reconstruction, in where you have time on the x-axis and the transect over the y-axis. And you have the different variables here I'm showing for ease, backscatter, sedum, phycocyanin, and chlorophyll. And there are many things to be said about that, but I will focus on a few of them. First of all, we were able to detect blooms very early in the year, way before any other monitoring effort did. And so, like for instance, here we saw a pretty high, a relatively high chlorophyll concentration, but a high chlorophyll concentration, but a relatively low phycocyanin concentration. And we went to see what it was. It turned out it was a different species that we were expecting. A little bit later, it was some other different species, and you can see the color of the water varies quite a lot. Later in the year, again, kind of like pretty high chlorophyll blooms with also high phycocyanin values. You can see that these two dots over here, they are attached. So these correspond to two different blooms and that are not connected. And so again, checking on that, there were different species and how they looked, it was different. And so here we got the Microcystis aeruginosa, that is our main interest of species of interest. But what I actually want to focus now is this event. I think this is pretty cool. And so here you see a slope. So basically, because this is time and this is space, what it means is that a bloom originated here and it was moving in space towards what in the map will be this direction and how it goes. And so that motion repeated again here. So you have again a slope, but you then have a blob. This expands over here. It corresponds to the growth of the bloom. When you see a slope, it is motion. When you see it growing in a circular pattern, that is growth of that. But then later in the year, the direction of the motion changed. And so you see the slope is in an inverse direction, and then it happens again here. And so that should be related to the circulation of the lake. And you see that in the chlorophyll, you see that also in the phycocyanin, and you see that different relationships between chlorophyll and phycocyanin for those. You also see signals in sedum, and there is something to be told about that, but there is no time for that discussion. So I'm just going to jump quickly to this event particularly. So this event was for me pretty interesting, because you could actually track it. And so here's what I'm showing. So these are the different tracks or transect that I separated for that time. So this is an event between May and June for a few days, for a couple of weeks. And so I separated a different transect. So one track will be one pass, another pass. And so in here you had like 9 passes in this period of time. And so you can see them in color. So the first pass, it's a lighter color. The last pass is a darker color. And again, because it's a continuously moving around, it can be day or night. So the tracks that are totally during the night are marked as dotted lines. And so you can clearly see the motion of the bloom towards the northern side of this transect. And we estimate that to be between 1 to 1.5 kilometers per day, which is pretty fast. And when you separate it like that, you do see an effect on the day and night. So when you look at them together, it's kind of like different to see. But like here, for instance, when you compare the 8 and the 9 track, you can clearly see that the 9 track was totally during the night. It has a lower chlorophyll signal than that. The same can be said for like the 5th and the 6th track. It's kind of like in the same very close together, but you see them a little lower concentrations. And then we went ahead and with like kind of like thinking in what this variability means and what it does, we went ahead and we looked at what will mean if you aggregate data in different space composites and what does that mean in terms of variability. And we could find out that if you actually average the content of your measurements in a 4 kilometer transit, in a 5 kilometer transit, you are increasing the order of magnitude of your variability in 1 to 2 orders of magnitude. So there is a lot of variability going on in 5 kilometers. So when you translate that, for instance, to a satellite image or something like that, you still can catch motion even at 10 kilometer resolution, but this motion is pretty much decreased. A word of standardized validation, because I kind of like I'm going over time here. So what we call that, this is something that we use for sensor validation and cleaning. So this is a method that was established to kind of like outside of the field, see if your sensor is performing well, to capture biofilm and sensor drift. And so we perform these checks before and after cleaning sensors. And so basically what that told us is that the signal, if it changed quite a lot or not, because of that. And usually we had a very clean, we found out that 2 weeks was a good enough time in this environment to not cause much change to that, except perhaps like this one time that it got. But it was a good way of checking if our data makes sense or not. And so this is based on some practices. And we found out that this is a really, really good and quick method for validating your data and getting like an idea of like a long time deploy things. But my last word is on validation is that when you compare sensor data, when you do calibration curves on the lab and you go to the field in a very, very turbulent environment, you do not get good performances. So here I'm showing you, for instance, this is 5 minutes before and 5 minutes after the Vila sample time series on like the colors at different times versus lab measurements right under the boat. And they do not compare. So like the triangles are lab measurements, the dots are the time series of the sensor. And so they really not comparing. When you plot an XY graph, they really don't go well in that. And so what we are currently using are posteriori validations. And we found out that is needed is a way better understanding of how fluorometers work in turbid environments. And I think I'm going to stop here. That will just like want to give some acknowledgements of what this was a very huge effort of a lot of people working in the project. I want to recognize the Navotion people who like built the boat, the GCOS people who communicated the data, and like a bunch of people that work in Harbor Branch for making this possible. And I will just perhaps just leave this in there for comments. And we'll stop here.
Thank you. That was great. And I appreciated hearing the talk you gave on in Socorro too, and really glad you could do it. Looks like there's one hand, Dr. Pearl.
Hey, can you hear me okay?
Yes.
Okay, great talk. Really nice and very comprehensive. We use a lot of fluorometry in monitoring in our local estuaries in North Carolina. And we found that there are very large differences between the time of the day and the fluorometric signal that you get. Have you looked at that at all? And I'm just curious how that works out in your quantification.
It is hard. There are many things coming into, so because like I haven't even shown you the values of our measurements because they are totally crazy. It doesn't mean, like, to me, and I'm a physical oceanographer, so to me chlorophyll values are just a number. I don't know what they mean. So when I was looking into that and just like seeing variability of data, it was like, how can you even do that? And the answer is the sensor is largely under the hull of the boat. The boat is small, so you are taking the measurement say, I don't know, Scott, correct me if I'm wrong, but there's like, I don't know, like 10 centimeters under the water or something like that will be. So I think there are many other things that will affect that, like from like just the patchiness of that, from just like the turbidity, the patchiness and the turbidity of the lake. It's a very, very turbid water. So I don't know if light in that sense from the internet will affect that much that, as it will be perhaps the migration of the algae, because these things are like pretty buoyant and they can migrate vertically. So there are many variables in that variability. So to think that it is late day or night, I don't think we even like approach that, because then you will have to be taking samples for validation of that, and we didn't do that. There are so many other things.
Yeah. Well, that's, it's a physiological question, really. The fluorescence, increases or decreases depending on the light flux. And for us, it's a problem because, we have like a TMDL on one of our estuaries for chlorophyll. So, depending on what time of the day you measure, you may meet the TMDL level or not. And so, we always have to do extracted chlorophylls in order to, calibrate that as well. I think for the kind of study that you're doing, I think the stuff you presented is great. But I think in a management context, it could be problematic if you don't have extracted chlorophyll values to go along with it.
Yeah, and I think that is one of our next steps, is kind of like conduct very, very serious high frequency validation of that, like what will happen across a turbidity gradient, what will have, like we also have like some sensor drift due to temperature, just like seasonal temperature that also occurs. We can see that in the SAT-nice curve.
Yeah.
So yeah.
Could you have your sailboat just run around and do a diel?
A what?
A diel. Just have your sailboat just out there on the bloom for a whole day-night cycle.
It was there all day night, like during 2 weeks, like for all of the missions. So
yeah, so you should be able to see some, what the degree of variability is there. Yeah, of course it's patchy too. That's another problem.
Yeah. Yes.
Thank you.
Could I make a comment too? Hi, Hans. Good question. I think that's a really great question to ask, because I think it was what I think we overall found is that on a relative basis, the sensors seem to perform pretty darn well. It was difficult to get them to a quantitative accurate, like you're saying, that would be, really meet TMDL type of interest and things like that. Was probably not where we were at with the sensors at this time, but the relative measurements were pretty darn interesting. And you'd see these kinds of patterns that Veronica was mentioning from a mission operations perspective. It was really cool because you'd see where the variabilities came up, and you see where increases in chlorophyll were, even if you didn't know the exact concentrations, but you could still know that something was going on. Yeah. And with enough time out there now and then on the lake, you could occasionally get a chance to validate what was going on. You'd see the sensor's relative variability is corresponding to a Microcystis intensive bloom over here, or some other kind of a bloom, Deletiospermum or one of the other ones. And you could start to see those differences in patterns. And then from a mission operation perspective, you could look at the values coming in and say, we know that's almost for sure a certain species of algae, or it's not Microcystis, for example.
Yeah, no, it's very useful in that regard.
And we also found with oxygen sensor that was really interesting diurnally, because you would sometimes see really high growth rates in the early afternoon or evening when the sun was really increasing temperatures. And then at nighttime, the algae would start to die off, and the oxygen levels would diminish dramatically. So there were some very interesting patterns overall that were deal variations that would be interesting to do more with that. But anyway, that's.
Yeah, well, thanks. Great talk.
Thanks, everyone. I think if we can move any other questions possibly to the chat, if the speakers will be able to stay on for a little bit, and move to, we have Randy Turner up next. I think Marissa was going to introduce his
right.
talk. Thanks.
Thanks, Becky. Yeah, this is Marissa. I'm going to introduce the talk. We're going to continue talking about technology to support monitoring. So Randy Turner and Lauren Sim of the San Francisco Estuary Institute, or SFEI, which we often say for short, will be giving the talk. And I just wanted to highlight a couple of things. So, this is a joint project with the water boards, and we're going to be talking about API. And that term might be unfamiliar to some of you, and they're going to be defining this really well. But generally, it's a tool for data sharing between one system to another. And we're going to be talking about satellite imagery and how you or your organization can better get satellite imagery that's been processed the way that you want, or data analyzed the way that you want for your tool to look at the satellite imagery. Or we can maybe expand our existing satellite imagery tool that's hosted by SFEI to provide that. But this API will be a mechanism to be able to provide data that you need. So we also want to hear from you, after during Q&A, and also follow-ups. Please feel free to reach out to Randy Turner to continue discussions. Because again, this is, we want to provide a service as well, and improve the satellite imagery use in California to remotely sense chlorophyll and the cyanobacteria index for cyanohabs. So I'll hand it over.
Great. Thanks, Marissa. Great introduction. And, thanks for the state board for providing the funding for this project. And I also want to thank Lawrence Sim, who's my colleague and does so much of the work behind the scenes with coding and getting the tool to be functional and as pretty as it is. So got to take my hat off to Lawrence for all his help here. Marissa kind of gave us the brief intro. If we want to, Lawrence, if you want to go ahead and start the slides. All right, and you can go ahead and advance to the next one. All right, so I'm not sure how many people have used our satellite analysis tool before. You can go to it at the fhab.sfei.org. That the tool itself has been live for 6 or so years, and it uses the imagery from the Sentinel-3 satellites to estimate cyanobacteria abundance in kind of near real time for large water bodies. It covers about 250 water bodies across the state. About 100 of those are, on the small side that, we get some data for, but it provides, just a good estimate of, what is growing in there at any one time. There are I can go to the next slide. I'm going to just try to keep this kind of overview very simple and focused for today. We've discussed the tool in different formats before, different forums, but basically, the main, kind of key piece here is the spatial data that it can provide. The tool itself has a pretty user-friendly interface to kind of look at conditions across the state. And, the map here we see on the left really gives you that visual using kind of a heat map approach that tells you where the concentrations are higher in red and, lower towards the cooler colors, and then where there is black cells that is basically at a background concentration. So this is going to give, basically that estimate of cyanobacteria concentration for a given period of time. And in this case, we display data over 10-day periods of time. So compositing all the imagery from 10 days. When we look at some of the data that then provides, we can see long-term trends for concentration in the upper oval here. So we can see concentration change over the course of years. And then in this lower oval, we can see kind of some of the stats for mean, median, and 90th percentile concentrations over a shorter period of time. And that's adjustable between 10 and 90 days based on some of the drop-down menus you can select. So it gives you a better idea of how those trends are occurring if you need to respond to a bloom itself. All right, next slide. There are a lot of other kind of little key things in this tool that you can use on its own, but our focus today really is on how to get data out of the tool to be useful for you. So there's different graphs, there's imagery, tables that you can download if you want to use it in for a report, or to pull that imagery into ArcGIS or other programs. So how can we make this useful for you is really kind of a key point here. So one of the things you can do is you can pull out the graphs that are below the oval. You can just download it directly as images to put into report by clicking on the button there in the oval. So that's a real simple way to get some general stats. All right, next slide. And then there's a couple different ways to get imagery out itself as basically, I think geo-referenced TIFFs, if I'm saying that correctly. Lawrence can get me on that, but there's ways where you can get it here. It's shown how you can get the imagery for individual water bodies, and then you can select the date that you want, as well as whether you want the 10-day composites that we display on the tool itself, or you can change to just get the images from an individual flyover. Often that is helpful when you're trying to look at blooms that appear to be crashing, because the 10-day images will give you still, kind of bloom conditions from 9 days ago that may not be as, up to date as you can get from the individual flyovers. And there are other ways when you back a little bit further out of the tool to the statewide level, where you can download these same types of images for the entire state, for all the water bodies, but just keep it simple here on this presentation today. Next slide. There are also some tables where you can download some of the statistics this way, either for the water body wide data based on the satellite imagery, or any seeding data that's available for the water body that relates to HABs. So this would just basically give you a CSV table that you can download directly and use as needed. All right, next slide. And so there's a lot of value in just how you can navigate the tool and get this information, or observe it on your own. But really, we want to look at kind of alternative methods that people might need to get that data into their own, their own programs, whether it's ArcGIS or other software. How do we kind of meet your needs is really the key question we have. So we're going to have Lawrence talk to you a little bit about that application programming interface, or an API. Lawrence will give a kind of a brief demo after he gives you the basic definitions of what this is and a few analogies. And moving forward, we really want to get your input, as Marissa mentioned at the beginning, on what additional features or additional data sets or other functionality should we prioritize to help you meet your needs, whether it's as a lake manager, or as a public health official, or someone working at a regional board. How can we utilize this tool to better suit your needs? So whether that's through just questions and answers today, or follow up later, or there is a technical advisory committee that Jamie Smith from SQUIRP is leading up on remote sensing. And so, your involvement in that TAC could be really beneficial too. So just want to plant that seed, but feel free to reach out if you have any questions or suggestions. So I'm going to transfer it over to Lawrence right now to give you more of the background about the API that goes a little bit above my my pay grade of understanding.
Thanks, Randy. Yeah, so one of the initiatives we're developing right now for kind of the phase 2 of this whole suite of tools is a web API interface that kind of complements the FHAB's web app and potentially might kind of help out a lot behind the hood on actually how that web app is operating. But just a quick overview on web APIs. If you're not familiar, and if you Google it, you could get a lot of very technical pages, and even the term API is it's a little much. Basically, you know, for the purposes of this, you don't need to understand all the back end, but just what it does, how you interact with it, and what benefits it provides. So at the highest level, a web API is just a protocol. It's just agreed upon set of methods for requesting data. Requests are just made via URLs for a web-based API, which is just like your browser and going to a website. And in this case anyway, the goal here is to return more raw data. So you have much more direct access to data that's a lot more adaptable to programming or coding. So it's a little bit more raw, but kind of powerful that way if you can use those tools. This is a graphic I just pulled off of, this is probably the more accurate version of an API. The client is you, someone on the web browser. The database is what we have, and the REST API is the interface in between it. But a cleaner way to think of it, a common analogy given is the restaurant analogy. You're the customer, we're the kitchen, and the API is the server. Although I like to think of it a little bit more like a menu as well as the server, because you know it's not a human. You're not speaking to it in sentences, but you have this agreed upon protocol of routes that you can request. And not only do you have routes, you can customize the routes in certain ways. Say if you're ordering a steak, you can choose your doneness, the different sides. Routes are the same way, where there's a general format, and that format might have different degrees of flexibility. And a restaurant analogy, another way just to show the benefits is, in this case, maybe you're a developer. So you're the kitchen, you're the restaurant, and you want to build this new dish. You don't build a new dish by getting finished products from other restaurants. You know, you're not gonna make something by ordering plates from other restaurants, taking it apart, putting it back together the way you envisioned it. In that case, the API functions a lot more like a grocery store or something like that. It's a lot more direct access to the raw ingredients. In this case, the raw data. Our website's very nice, it's very pretty, but if you want to programmatically pull stuff from it, it can be, you know, it takes a lot of human control, and it's somewhat, from a programmer's perspective, maybe a little clunky. You're kind of crawling through the web page, copying and pasting these tables, trying to extract the values. Just to give you, right before we jump into the demo, this is what a web API request looks like. This is just a URL. This URL doesn't work yet, but the live version, once publicly accessible, would be something like this. And on the top, you have the root, and within the curly braces, you have the different parameters. This is the format. And some of these, especially the ones at the end, might be optional. In this example, the last two are. But just for the full example, and in the bottom, just below that, you have the URL as it would look if it was filled out. And basically what you're saying is, for the product, I want CI Cyano. For the composite, Mosaic, so compared to the 10-day composites we serve, we just want the Mosaic single date. Water body ID, you have to look that up, but water body ID 33 is Clear Lake. From this date to that date, return me raw values, raw pixel values, give it to me in a CSV. So it's kind of like constructing a sentence, but in a programmatic way. So I think at this point, I'll just kind of jump into the live demo because I think it's a little clearer this way potentially. This is the documentation page. There are some user examples here. This is just a way to kind of build API routes. So for example, if you're searching for Clear Lake, this is a route to search for a water body. So the URL format is water body in your search terms. But just to give you an example how to build it with the user interface, this is the result you get. And it builds the route for you. And if you look at this route, so this is in Firefox, which has some nice ways of looking at things. This is what the raw data looks like. This is kind of prettified. This is JSON. This is great for plugging into code. And Firefox also has this kind of JSON. It builds it into the object that it's actually representing. So that's kind of nice. And won't go through all of these, but for example, we can already, this is live, just not publicly accessible yet. We can already start offering things that we don't have on the site because this is just raw data requests. We don't have to build a user interface around it. So for example, we don't serve Mosaic stats, but you can look up Mosaic stats pretty easily in this route. Again, this is something you would build on the URL, but this is kind of a nice thing that gives you a way to build it visually. You submit that. It'll take a second because this is actually reading the raster values. And it'll give you this data out here. And if you click the actual result page, the route URL, this is what the actual data it's giving you looks like. So yeah, and we have other routes and we're building a few more. I'll just show one more for example, but downloading rasters. So just like that, but I'll click the actual route. That doesn't make a difference. But anyway, yeah, just by making this URL request, you can instantly get the raster you're requesting. And you can see how, because it's this URL request, it's pretty easy to just swap out the date values. You throw that in a Python script, you can download, just cycle through all the dates you need to get. And more in terms of new routes we're developing, this one I'm just playing with and got it started is pixel value requests. So Cyano, Mosaic for, I picked the random date here, but for July of 12th of 2 years back, this longitude, this latitude, and you're going to get pixel values. In this case, we get 2 because there were 2 flyovers from Sentinel A and Sentinel B on that date. Although Sentinel B had no data, so that's why the null is being returned. So that's a really quick rundown, but yeah, we'll have time for questions, but I'll pass it back to Randy real quick for our next steps.
Yeah, and I know it looks complicated to many folks who aren't programmers, and I'll raise my hand there. One of the things that I think it will really help folks with is if you're trying to automate the ways that you pull data from this site. It can be set up that way through the API eventually, where you can have it pull data every day automatically. So you have to get that kind of programmed in, but it should help kind of reduce the amount of labor to get to this data. So while it does look rather complicated, we do want to take questions from you about kind of what your needs might be. If there's other data that you want to see in the tool, or other ways to get data out of the API. Kind of what priorities would you have? And it's kind of hard to make it just to where we want your data, what we want your feedback now, but we want to kind of open up that conversation. So I mentioned the TAC that Jamie Smith with SWIRP will be starting here. So if there's opportunities for you to join that technical advisory committee to provide input and be working with them to go through what those priorities are, and get your feedback, and that's one method. And so anything, that you can provide to help make this tool better and more useful for you, that's what we're really, looking for. One piece, one data set that we are beginning to explore is, besides the cyanobacteria data from, from the satellites, actually looking at pulling in chlorophyll data as well. So, there's, different algorithms. It will come from the same satellite. So we'll be able to, pull this data in rather easily into the tool itself. And so that, chlorophyll data will be used for different reasons. So we're looking forward to, getting that integrated in the tool. So that's just one, I guess, example of something else that we're working on, but want to really leave time for questions. Does anybody have any, API questions or questions related to the tool, or what else we can do to better serve your needs? Karen. Karen,
Hi,
go ahead.
Randy.
Hi.
When we were starting to develop this years ago, we had this vision that this was going to be used for water lake managers to guide their monitoring, as far temporally and spatially. And it seems like it's not being used, at this time for that. And I'm wondering what the problems have been. I know that it seemed like it was very straightforward in the beginning, but it turned out not to be as straightforward as we may have thought. Is it just a resources issue, or?
I'm trying to kind of wrap my head around that question. The tool is available to anyone, publicly, and one component I didn't mention is, if a lake is not in bloom, but then the next day it, some cyanobacteria is detected by the satellite. Once it reaches a certain concentration, crosses the threshold, there are emails that automatically go out to regional board staff and others to kind of announce that a bloom may be forming. And the goal there is to help guide monitoring efforts that are needed to, detect if there are, toxigenic species within that bloom, and or to guide, toxin testing to help from a public health perspective. So, that is in place. I think, expanding the list of the, who those emails go out to could be a way to get that information into lake managers' hands better. We can talk about that with the state. Does that get to your question?
Yeah, that helps.
Was it more operational?
I haven't been involved in a while, being retired, but
yeah.
I'm just dropping in, and because I was interested to see how this was developing.
Yeah, no, it's great to see again. I think because this has been funded with from the pot of money that relates to public health and recreational contact, we haven't incorporated needs of like the drinking water community, to provide information about whether blooms are happening near drinking water intakes. So it doesn't have that nexus as of yet, which could be another kind of operational concern, whether it's for lake managers or drinking water providers, but it has that potential. So if there is a need and we can interact with those staff, perhaps there's other steps we can take to expand the use for that tool.
Yeah, that seems like a good idea. Yeah. Well, thank you.
Thanks, Karen. All right, any other questions? And I can I would be scared to ask questions about the API specifically, just given how technically complex it looks, especially at first glance. But we're happy to take questions offline. We have my contact information up there. So definitely feel free to reach out to myself. And Jamie, do you have any quick words to say about the TAC, the Technical Advisory Committee?
Yeah, sorry. Thanks, Randy. I just put my email address in the chat. So if you are interested in joining the TAC, please either email me or Randy, and we talk to each other. So I just say, you know, if this is of interest to you, we would love to have you on the TAC, because we're kind of the TAC we're trying to populate with a lot of who would be the interested end users to help guide kind of how we're developing this. So let us know.
Great. All right. Well, thanks for the time today. I appreciate it.
Thanks, Randy and Lawrence. Yeah, so I know we ran short on time, so I put a update on where the outreach has been from the illness work group and some of the resources that we put together, including new Spanish versions for the marine hab related stuff that I know was relevant to what Rebecca Nordhout was mentioned with San Francisco Bay earlier. As a reminder, we have our next quarterly meeting. We have January 18th. We do a longer sort of year-end review meeting for that winter meeting, and hopefully people have a little more time on the quote unquote off season for HABs that are more and more year round for a lot of water bodies, but you know, relatively less active. And look forward to that. We'll stop the recording. That'll be up in the YouTube channels through the Water Quality Monitoring Council probably within a couple days. And if you have any suggestions for the January agenda, please let us know. And any final thoughts, Jamie?
No, I don't think so. I think you wrapped it up perfectly.
Great. Thanks, everybody.